So in the last video, we talked about significant figures and how the number of significant figures in a measurement speaks to the level of precision of a measurement. So that begs the question, well, how do I know if a number associated with a measurement, how do I know it's significant? So which numbers are significant? So to determine significant figures, there are a few rules to follow. First is that all non-zero numbers of a measurement are significant. So example, this number 3.34, all of those numbers would be significant. So this number has a total of 3 significant figures. So all non-zero numbers are significant. Zeros that are in between two non-zero numbers, those are called interior zeros. And those are also significant or speak to the level of precision of a measurement. So in this number, 3.034, obviously both 3's and the 4 are significant because they are non-zero numbers. That 0 is an interior zero. So this measurement has a total of 4 significant figures. Zeros that are trailing, meaning they fall to the right of a non-zero number and after a decimal point are significant. So in this answer 3.03400, obviously the 3, both 3's and the 4 are significant because they're non-zero. This interior zero is significant due to rule number 2. And these final two zeros are trailing zeros. They are to the right of a non-zero number, specifically the 4, and they fall after the decimal point. So this number has a total of 6 significant figures. All of those digits are significant. Trailing zeros that fall before a decimal point are also significant as long as they come in between two non-zero numbers. So for example, in 1700.24, this number would also have a total of 6 significant figures. The 4 non-zero numbers and those 2 zeros. So all of these are examples of numbers that are significant or do speak to the level of precision of a measurement. So which ones aren't significant? There are 2 main cases that you need to be familiar with, and they involve zeros. There are 2 types of zeros that are not significant, meaning they do not speak to the precision of a measurement. The first one are leading zeros. Leading zeros, by definition, are to the left of the first non-zero number. So, for example, in this measurement, 0.023, obviously the 2 and the 3 are significant. They are non-zero numbers. But both of these zeros are considered leading zeros. They are to the left of the first non-zero number, specifically the 2. And since they are to the left of the non-zero number, they are not significant. They do not speak to the level or the precision of the measurement. So this number, 0.023, has a total of just 2 significant figures. The final case of zeros not being significant are trailing zeros at the end of a number, but before an implied decimal point. And that's an important point, implied. You think about all the cases we have talked about with zeros and significant figures. We had to look to see where that 0 was with respect to non-zero numbers or the decimal point. Well, what if I have a number, like for example, 12,000, this first number here, and hey, I have no decimal point there. Well, since there's an implied decimal point, but there's no actual decimal point. zeros that are before an implied decimal point are ambiguous. You should read that to mean not significant. 12,000, this would be saying there were approximately 12,000 people at the football game. If I knew there were exactly 12,000 people at the football game, then I would have to show that level of precision by using a decimal point. And now I can say, oh, these zeros are significant because they are trailing zeros. So this first number, 12,000, it has a total of 2 significant figures. 12,000, all of the zeros in that number are significant because these 3 zeros, they are to the left of the decimal point. This 0 is to the right of the decimal point. So this number, 12,000 with the decimal point, has a total of 6 significant figures. This first number would be, there were approximately 12,000 people at the game. The second number, I counted all the tickets, I counted all the seats that were filled. There were exactly 12,000. And with regards to exact numbers with respect to conversion factors, this will become more important in later videos for Chapter 2 and beyond. But numbers that are part of a conversion, like for example, 2.54 centimeters, 1 inch, or things that you count, like 3 atoms or 3 pennies, those are exact numbers and have an infinite or unlimited number of significant figures. So, for example, looking at this equivalency, 2.54 centimeters and 1 inch, you may think, oh, well, that measurement just has 3 sig figs, that just has 1. But since it is part of a conversion factor, you can think about it as being exactly 2.54 centimeters and exactly 1 inch. With regards to things that you count, like atoms or pennies, there isn't half an atom or half a penny. It's exactly 3 pennies or exactly 3 atoms. So those exact numbers have an unlimited number of significant figures. So those are the rules for significant figures. If it sounds confusing, take heart. We're going to do some more examples in the next slide. I would say the 2 rules to be most familiar with, because they are the exceptions for numbers that are not significant, involve zeros, ones that are leading zeros or trailing zeros before an implied decimal point.